Okay, objective 3, measuring angles. You're going to see a lot of similarities between what we're doing with angles and what we did last time with segments. There are a lot of similarities there. So first off, some definitions. An angle is a figure formed by two rays or sides with a common endpoint. And the vertex of an angle is the common endpoint of two rays or sides, basically where the two rays meet, or the pointy part. And because it's one of those weird words we got from Latin, the plural of this is vertices. So in the example above, angle CAR, the A is going to be the vertex of the angle. Now when we talk about angles, just as there was certain things we had to do for lines, we talk about angles, there are three different ways that we can name them. The first way is by the vertex and a point on each ray, and the vertex must be in the middle letter. Basically, as you follow the points around the angle, you're going from one ray to a vertex to another ray. So this angle here would be named either angle TEA or angle AET. Now a second way is you can also name it by its vertex if there's only one angle. So we can also call this angle E, because E is the vertex. And then finally we can call it, just if it has a number, we can just call it that angle. So this is angle 1. Now you say, okay, why are the different ways here? Well, method number 1 is kind of like, you have a first and a last name. And so if I'm trying to identify you specifically, then you might call you by your first and your last name. Or if you get in trouble with your mother, then you use your first, middle, and last name. But if I'm just talking to you, if I just want to refer to you casually, I can just say your first name. Well, which is fine unless there are more than one of you with the same first name in a class. In that case, if I call you by your first name, that can be confusing. So the same thing with angles. Angles, you can call it by just its vertex if there's no possibility of being confused. If there's more than one angle around a vertex, then you're going to have to use one of the other two methods. Because if you just call it angle E, and I don't know what angle you're talking about, that can be a problem. So if I've got this angle here, so I've got 3 points here, I've got a number. Which of these is not going to be correct for this angle? Well, again, remember your vertex has to be in the middle. So the one way that you cannot name it is angle RST, because my vertex R is not in the middle. So just to refresh your memory about some definitions, an acute angle is an angle that's between 0 and 90. A right angle is exactly 90 degrees. An obtuse angle is between 90 and 180. And then finally, a straight angle is an angle that is exactly 180 degrees. Now, this also happens to be an opposite rays, or you can just call it a line. It's all the same thing here. Congruent angles are two angles that have the same measure. That means they're the same size. So if one of these angles is 45 degrees, the other one's 45 degrees. And just like with segments, we use tick marks to mark them. On angles, we use what are called arc marks. Arc marks, you can match up to say which angles are congruent to which angles. And so, again, we use our congruent symbol if we're talking about the angles. We use equal symbol if we're talking about measures. And so when we talk about how big an angle is, we put this little letter M in front of the angle, and that stands for measure. So if I have M, angle symbol WIN, I read that as the measure of angle WIN. When we talk about angles, we have what are called the interior and the exterior. I'm specifically working here about the interior of an angle, which is the set of all points between the sides of an angle. If I've got a point in the interior of an angle, that actually leads me to my angle addition postulate, which essentially, just like the segment addition postulate, says that the part plus the part is equal to the whole. So if I have an angle, if I have a ray that goes through an angle, and so in this case I have angle ABD and angle DBC, that make up the angle ABC. If measure of angle ABD is equal to 50 degrees and measure angle ABC is equal to 110, which is the whole thing, then the other angle that I don't know is, I take 110 minus 50 and I get 60. So for example, I have angle PAH, which has ray AT in the middle of it, and the measure of angle PAH is 125. So to solve this thing, I know that the measure of angle PAT plus the measure of angle TAH is equal to the measure of angle PAH. So again, part plus the part is equal to the whole. So 2x plus 8 plus 3x plus 7 is equal to 125 degrees. Combine my like terms. So I have 5x plus 15 is equal to 125. Subtract 15 and then divide by 5, and I get x is equal to 22. Now an angle bisector, again, a segment bisector divided the segment into two pieces. An angle bisector divides the angle into two pieces. So for example here, ray UY bisects angle SUN, which means that I have two congruent angles, or I can say the measure of angle SUY is equal to the measure of angle YUN. For example, angle PUN is bisected by ray UT, and the measure of angle PUT is equal to 3 plus 5x, and the measure of angle TUN is equal to 3x plus 25, and I want to know what is the measure of angle PUN. Okay? Now, one thing that I was seeing when we were talking about the quizzes and things is that some people want to just say, well, I can just add them together. So I've got, what is this, 8x plus 28. Okay, so that's my answer. Well, no, we're solving, we're almost always, you're going to be setting up an equation, solving for something, solving for your variable. And so in this case, whenever I'm dealing with bisected, that means I have two things that are the same. So I'm going to set them equal to each other. So the measure of angle PUT is equal to the measure of angle TUN, because again, it's bisected. So there's two pieces that are the same. So 3 plus 5x is equal to 3x plus 25. I subtract my 3x, I subtract my 3, and I get 2x is equal to 22. Divide by 2, and I get x is equal to 11. Now the question was, what is the measure of angle PUN? PUN is the whole angle. So what I can do is I can take one of these halves, one of these two pieces here, plug in my x, and then whatever I get, I just double it. So if I take 3 plus 5x, plug in my 11, I get 58. 58 times 2 would give me 116, so that's going to be my answer. Another example, kind of looking at it a different way, point R is in the interior of angle NFL. If the measure of angle NFR is equal to 7x minus 1, and the measure of angle RFL is equal to 3x plus 23, what value of x would make ray FR an angle bisector? So I'm not saying it's an angle bisector, I'm saying what would make it an angle bisector? Well, if it's going to be an angle bisector, then these two angles have to be congruent, which means that 7x minus 1 needs to be equal to 3x plus 23. Again, moving variables, moving numbers. I get 4x equals to 24, which means x is going to be 6. Which means that if x is equal to 6, then ray FR is an angle bisector. So before we get to class next time, please make sure you've written your summaries for Objective 2, because I'm going to be checking for that. And then make sure you write your essential questions and fill in any kind of notes you think you need to for these notes. Bye-bye.